Yeah, welcome. So, in this class, we are going to be getting into the second part of object oriented programming, OOP part 2. So, in the last session, we stepped into OOP and we tried to understand, some important concepts about the fundamentals of object oriented programming. Why do we need it? What is an object? What's a class? What's an attribute? What's an instance attribute? What's a class attribute? What is um, methods? Was an instance method, a static method, a class method, and things like that. Then we look at some basic example of how to structure um, our class. So in today's class, we are going to be stepping into the second part, and what we are going to be looking at is some important concepts in OOP. So, like I mentioned in the last session, I talked about the fact that object-oriented programming is a programming paradigm, is a way of writing program. It is not something that is limited to Python. It is across different programming languages, and it is just an idea, right? A way for you to do things, a way for you to write code that is compact, that is easily reusable, that is understandable, and that is you can think of it as industry standard, right? So now, having let's just take a quick you know refresher over what we did in last class. So let's say we are creating. Let's create. Let me zoom this in a little bit and say OOP part 2. Is that excuse me? Here we're gonna have right OOP part 2. So let me delete this right here. Then perfect. So we are going to just create a bank object, something that mimics what we have in a bank, just to give us a quick refresher. So we can go, let's say we have, excuse me, class, and we can go bank account. So in that case, what we're going to have is we're going to have our constructor first. And don't forget, I mentioned in the last class that this, starting off with capital letters is like a standard way of creating objects. Whenever you are defining a class, the name of that particular object that you are creating, or that class that you are creating, is going to be in capital letters to start. So the next thing we want to do is we define the constructor, and I mentioned that the constructor is different from a normal function or a method because it has this dunder in it, double underscore in it, double underscore. Then inside that we pass in self, which I told you is referring to the instance of that object whenever we create a new one. And that's the way Python gets to tell different instances of that class apart from each other. So let's say, balance, and we can have the name of the holder, account holder. And if you remember the class from function, you can actually annotate these ones. You can do type int in here, so we can say this is expected to be an integer and this is expected to be a string, and we do not expect constructors do not return anything. The only thing we do inside constructor is define attributes. So I'm going to say self dot balance that is going to be equals to our balance that we have here, and self dot count holder that is going to be equals to account holder. Also, we can do things like maybe account type and stuff like that, whether it is a savings or a deposit or a current account, stuff like that. So let's say this is everything that we have here. There are no methods inside this class. Let me just run this. And the only thing that we're going to have is, let's just create an instance. So you're going to say um main account, or let's say company account, or let's say account one, and that's going to be bank account, and it's going to take balance. Let's say balance is 5,000. Balance should not be int, actually, it should be float, because you could have anything, any kind of number, even decimal. Then we're going to say account holder, and the name of the account holder is going to be John Doe. Yeah. Now, so if we go ahead here, and this is basically majority of the things we copied in the last class. So we've created the account here, so we can come here and say account one dot balance, and if we run this, we are going to get 5,000. And from what I showed yesterday, in the last class, from what I showed in the last session, you can actually modify these things. For example, we could go account balance equals 45, and run this account one balance. So if I should come here and say account one dot balance now account one balance has become 45. And don't forget, this is on the side of the user. Like, when we created this old stuff, let's say this is a real bank application. We're just assuming, and we have this. We've already created this instance and all of that, and the person's balance is 5,000. After this creation here, we are not supposed to be able, like standard way of writing code, we are not supposed to be able to just say account one dot balance and set this thing outside of a method in this particular class. What does that mean? If we are going to be changing variables or changing attributes within this class, that is for any object, we should have a method that does that. And then we can now put maybe some guardrails, some password and things like that, if you want to do that, or some privileges. So if someone can just come and say account one dot balance equals a particular value, let's say we set it to maybe 4.5 million, and just run that, and that's all it takes, then this is not a very very good program that we've written. We have not written this thing in the best way. So, and this idea that I just explained right now is what we call encapsulation, and that is the first um, concept, object-oriented programming concept that we are going to be covering, which is what? Encapsulation. So let me just put that here and say encapsulation. Now, no, number one, let's give that hashtag and say one. Now, what does encapsulation mean? So encapsulation is this OOP practice, is a concept in OOP, excuse me, and it is the practice of hiding the internal state. What I mean by internal state is the attributes, the data, self.balance, self.account holder. So it is the practice of hiding all of those attributes, and all of the interaction that's going to be with those attributes is going to be through a method. It is not going to be directly like this. It is not going to just be using account one dot balance, and you set it to another value. In fact, for you to be able to, even if you come here and say ordinary account one dot balance like this, you should still not, so you are not supposed to still be able to access this, because that's going to be like a simple case of just you accessing another person's information, just because you have access to the overall class. So what we are now trying to say is, in the idea that encapsulation is trying to preach is that we should hide all of these attributes, for each instance of the class, we should add all of these attributes, and any interaction with that attribute, whether we want to get the value of that attribute or we want to set the value of that attribute to another thing, should not be directly via you calling the attribute. It should be via another method that has been created for that particular case alone. So what does that mean? We are controlling who can see the attribute. We are also controlling who can modify the attribute just by practicing this encapsulation. Now we are going to actually put that on this class that we have here. And how do we do that? The first thing we do is we use something called private. So we use something called private. And how do we undo private? All we have to do is to just add double underscore here. So how does that work? We are going to say self dot dunder balance. Yeah. Say dunder. And there is a name in Python for it. I think it's called mangling or something. Then we can do self dot account holder also like this. Now, just by doing these two alone, if I should run this and go account holder equals this, then if I should run account one dot balance, let's just run it alone. We want to print out. If we do this, we are going to get an error. It says, well, there is nothing named account one dot balance. Bank account object does not have any attribute called balance. Well, you might say maybe that's because we've added this double underscore. Fine. So let's come here and say account one dunder balance dot, and we do run this, and it's going to give us this error. It says bank account object has no attribute dunder balance. Why? Even though we have it here, this is it here, it is not allowing us to access it. We've kept it private. So if we now want to see, if we want to see, if we want to see that particular balance, let's say we want to print out balance now, we are going to do it from a method. So we can have a method called get balance. So we're going to say def, excuse me, def, let's call it get balance, and it's going to take self. And I mean, it does not. If if let's say the person creates a password or a key or something like that, and you want to add that, fine, you can add that one here. Or let's say you are generating a token or something like that. But that is a little bit outside of scope of what we are doing and doesn't really have any application really in data science and analytics. But you can just imagine you are generating a token here. There's a password. You add that in here also. So I can now come here and say return. That's also going to be return self dot dunder balance this. Now, if we should rerun this now, let's rerun this, rerun, we create this account, and if I come here and say account one dot balance, it does not work, right? Account one dot ordinary balance, like I've shown you earlier, it does not work. Dot dunder balance does not work. And what is going to work? What is going to work is our getter method. They call these things getters, and there's another one called setters. So this getter, if we say get underscore balance and we run it, it's going to print out 5,000, which is this value here, right? Now, what have we been able to achieve? What we've been able to achieve is that now people can see the balance the exact way we want them to see it. Like we are the one controlling how they see it, how they get it. It's not just they can just run self dot balance and you're going to have no. So we are the one controlling how they see it. And any in fact, imagine I say password. This thing requires a password. Just imagine, and password is going to be, let's say, string, and I can go password. Let's have let's say user input. Let's call that user input equals input enter your password or your pin. Just call it pin. Then we're going to say if user underscore input equals password, then the next thing we do is let's tap this in, we return saved or balance. Else, we can return incorrect password. Now let's run this, and if we run this now and we call, okay, we have to set password to um they would have chosen a password. So let's say, yeah, we are just actually choosing a generic value here. So this is not a good this is not the correct implementation. So here we can come in and let's say at the point of creation, yeah, that's the right thing. So at the point of creation here, let me remove this. So at the point of creation here, we're going to have self dot dunder pin, and that's going to be equals to whatever pin that person chooses. So let's say they choose um let's say ABCD. Then we can say if user input equals self dot pin, self dot thunder pin, like this. Yeah. So if I should run this again and rerun this, now I want to get balance. If I should run this, it says enter your pin. Now it's not just churning out balance for me. Like I have this opportunity to ask them to ask for a pin. So if I should just type in something wrong, it says it should say incorrect password, and it's not showing us the balance. Now, if I should rerun that, not even that, I should actually not just rerun this one alone. If I should run this and go pin is ABCD, it says 5,000. So we've gone beyond just saying self the balance, where anybody can just come and check anybody's balance, right? We've gone to actually have a get balance method that help us to return the balance to whoever is calling it in our own way by implementing our own logic. We did this simply by just returning the whole thing. Then we upgraded it by actually adding a password. And you can also like make a generic input in this password so that anytime somebody hits this, they get an input, they create their password, right? So this is what I mean. You could do this, you could do input, say choose a password, something like that. And if you run that for every instance of this thing that we create, we can run this and it says choose a password, and we can go 1 2 3 4, and this has been chosen. So if I should run this now to get this person's balance, I can go 1 2 3 4, and it displays their balance, right? So that is encapsulation on one of the things we can do in encapsulation, which is get balance, and we call this thing getters. So I can say getters. Then another thing that we can do is setters, right? And where does that come in? Where that comes in is, earlier you could set balance to something. We could say account one dot balance equals 50,000, for example, like that, and run it, and it worked earlier. Let's do account one. Do we still have balance? If we do account one dot balance now, there is an error somewhere. Let us run this and run this. 1 2 3 4. Run that. Then we have this, maybe 1 3 4. Then if we do, let's check our account underscore one. So if we should do account one dot get balance, the ordinary balance, just balance like this. This should, yeah, so this is working all right. This should not work. Perfect. So if we come here now, if we want to set a new balance, like we want to actually call a new balance, if we do, if we come here, we want to create a new balance, like a new value for balance. We do that through a setter. So how do we do that through a setter? We're going to say def set underscore balance, and that is going to be, it's going to be self and the amount we want to set. So we can do amount. Then we can go here and say if amount is greater than 0, because then you don't want someone adding 0 or negative. So we are going to do self dot thunder balance plus equals the amount. That is, we increment the amount, and you can just do this at the point of return, or you can go back down and just say return. Let's do this at the point of return, or not. There is no problem. We can just return self, or we can return account, or let's say deposit successful. And you can do f string here and say you now have self dot thunder balance. Perfect. So I should come here and do what's that? Maybe dollar sign. Yeah, great. So we should run this. Let's say this person starts with this John Smith. Let's call this person John Smith, and they start with $150. We run that, and we run this. So choose a password 1234. Now, if we get their balance 134, it says the balance is 150. Now let's see if we can add a new and you don't have to call this thing set balance, you can literally call it deposit. So we're going to say amount, and that is going to be, because let's deposit $300, and we run that. Now what do we have? It says deposit successful, you now have $450. So if we go back to get balance and check their balance now, it says balance is now 450 because we've added um $300, and that is encapsulation. So again, what does encapsulation, what does it show, what does it show us really? It gives us this privilege, this opportunity to control how user access the state of our object, that is how they access the attributes in our object, and they cannot just directly access it, which is what happens by default in OOP. But what we try to do is set up getters and setters, and those two things help us to control. We set the term for how people access all of the stuff, so by inputting our own logic. And basically what encapsulation is all about is people should not be able to access those attributes anyhow. You should force them to do it through a function or a method, actually a method that you are controlling by yourself. So that is encapsulation, right? So now the next thing that we are going to be looking at is inheritance. I'm going to look at inheritance, and which is the second concept in OOP. Inheritance, there are four concepts actually. I don't know if I start with that, there is encapsulation, inheritance, polymorphism, abstraction. So, what is inheritance? Now, I mean, from the name itself, to inherit, right? So now, inheritance is an OOP concept, that allows a class, and we call that kind of class a child class or a subclass. Some people, I prefer to call it child class. So, but whenever you hear subclass, it's the same thing. So that allows a child class to inherit attributes and methods from another class, which is the parent class. So the easiest analogy to use in this case is the case of one create an animal object, an animal object. So now, or we can say we are going to define an animal class. So let's say we are trying to define a class for animals, and you know, we have dog, we have person, like humans, we have cats and stuff like that. If we keep defining um different classes for each of these animals, it does not make sense. Why? The reason why it does not make sense is because um animals share some basic traits in common, and they only differ with some little traits. It's not like the difference is like extensive. For example, we are all living things and we exhibit characteristics of all living things. So if you have to define a class for dog separately, you are going to write all of the method and attributes that you expect in a living thing. You write in that one, in the other one also, a lot of things like that. So you don't want to do that. So what you want to do is you want to have a parent class, aka animal class. So we say class animal, and we're going to have def. You have your constructor under in it. And if I have not mentioned this before, you don't always have to have a constructor. You expect to have a constructor in situations where your object is expected to have attributes, unique attributes, right? So if your object is the instance of your objects, they are not expected to have unique attributes. You don't need constructor. So it's a self name, and that is going to be self.name equals name, right? The name of the animal. Every animal, we expect every animal to have name. And next thing is, if you can think of any other generic things, I feel like every animal have legs. So you can say self dot. We can go escape and we can come here and say number of legs. Self dot number of legs. That's going to be number of legs. Then let's get to the method. So the method is going to be something like speak. Every single animal can speak, make some form of sound. So that's going to be self. And we're going to just return f string self dot name is speaking, or as is making a sound, right? Now, this is the animal class, aka the parent class. This is the parent class. Now, what we can now do is we can now have different um we can now have different other uh classes, aka child classes, that inherit from this. So how can we do that? Let's now say we need a class for dog. We just come here and say dog, and it is going to show inheritance. We have to wrap in this main bracket. We have to wrap this uh, parent class in there. So we say dog inherits from animal. That's basically what this means, and inherits everything basically. And we can now say def back, which is going to be self, and that can now say return, you know, f string self dot name is barking. Now let me define one more. and come here. No, let's see this for now. If I should run this, come to this place here and say dog equals dog. And now it is asking us for name and number of legs, even though we didn't define name and number of legs here, right? We didn't define it. We only define it inside the main, the constructor inside the main um, class, inside the parent class. But when we called dog, which is the child class, it has access to all of these things. That's because we've inherited it. So we can say name equals Bruno, number of legs equals 4. Then we can go dog dot bark, and that's going to be, if we run that, it says it's going to say Bruno is barking. If we do dog dot, let me show you something, dot speak here, and we run this. Now what happens? It says Bruno is making a sound. Why? Because we have, like I mentioned earlier, every single method that is inside animal, dog has inherited it. Now this now brings us to something called method overriding. So if I should come here and say def speak, then let me run this. Don't forget that animal, which is the parent class, has its own method called speak. um this guy here, dog, which is the subclass, also has its own what do you call it, has its own speak method. So if I should run this here and come here and run this, there's no back anymore because we've changed it to speak. So we can come here and say speak. And you might want to like pause this video and take a guess. Is he going to say he's making a sound or he's backing? Well, if you had said he's backing, then you are correct, because like I said earlier, this thing is called method overriding. So you can have a method in the parent class that does not really go along with how you expect it to come to life in the child class. So you can just override that, and the one in the child class is going to take priority. But every other thing that is in the animal class is going to uh, be inherited inside the child class, and that's the basics of inheritance. Now you can think of dog, this child class, as a specialized animal class, just an animal class that has more methods, and you can think of this thing. Now this is not a base class really. A base class is something that we are going to cover inside abstract methods, right? So but this is a case of inheritance, but you can think of this place as a place to start from, right? A place to start from. Now the last that we're going to be looking at in inheritance is um the super function. Now there's a function called the super function, and we use it to call methods from the parent class. And what we always use it for, especially the application that it has in data science and analytics, is that it helps us to extend the constructor, right? So what do I mean by that? So let's say inside um this dog, dog should also have breeds, but other kind of let's assume that other kind of animals do not have breeds. So only dog has breeds. So what we can do is we are going to have a constructor because we must add breed to this one. So we are going to say def thunder init thunder. Then after that, we want to pass in self name, number of legs, and um breed, breeds, or breed, right? So we can come to the next line and do this super function here, super, then thunder init. So what we are saying is get me name and get me number of legs, Get me name and number of legs from the parent class. That is, here we are calling the parent constructor, right? And we want to add our own breed here. So we are going to say self.breed equals breed. Now, if we should run this, excuse me, we run this. Now we can come here and say, comma, breed equals uh, shepherd. And if we run that, we are good. And if you do every other thing, self.name, don't forget that the only thing we have to explicitly define inside this new one is this particular self.breed. Why? Excuse me. Is this particular self.breed? Why? Because other things like name and number of legs, we've defined it inside the parent class, which is the animal class. And that is, the basics of inheritance and encapsulation in object-oriented programming. I hope it makes a little bit of sense. There are other things that you can have inside inheritance. You can have multiple inheritance, which you are going to be seeing as we move on in the subsequent courses where a class inherits another class, another class, another class. So like that. Um, that is the end of this session. It has been a long video, but I hope you're able to get some value out of it. In the next one, we are going to be looking at abstraction and polymorphism, which are the last part of object-oriented programming. See you in the next one.